Welcome, listeners, to another episode of Blue Planet Green Robots. I'm Mark, and with me is Tom, my partner in crime fighting, environmental crime, that is.
Thanks, Mark. Though I prefer to think of us as partners in grime, the kind you get on your boots after a day of fieldwork.
Speaking of fieldwork, today we're venturing into the digital wilderness of habitat connectivity analysis and corridor planning. It's like Tinder, but for ecosystems. Tom, imagine if we had a dating app for habitats. Swipe right for lush forests, left for barren wastelands. That's essentially what AI is doing for habitat connectivity analysis.
Absolutely, Mark. It's like AI is playing Cupid for Mother Nature. But instead of arrows, it's using algorithms and satellite imagery to create love connections between fragmented ecosystems.
You know, I once tried to play matchmaker for my neighbor's cat and ended up with scratches all over my arms. Thankfully, AI is much better at this than I am.
Let's hope so. But in all seriousness, these AI systems are analyzing vast amounts of data to identify potential wildlife corridors with incredible precision.
Right, and it's not just about connecting point A to point B. These algorithms consider things like landscape resistance, climate change projections, and even the dating preferences. I mean, movement patterns of different species. Now, Tom, let's zoom out a bit. How does AI actually turn all those satellite images into useful information for conservation planners?
Well, Mark, it's like teaching a computer to play the world's most complex game of connect the dots. Machine learning algorithms can spot patterns in vegetation, topography, and land use that might escape the human eye.
So it's like giving the AI a pair of those X-ray specs we used to see advertised in comic books. But for ecology?
Exactly. And these AI specs can see things like potential migration routes, genetic flow patterns, and even predict how these might change with climate shifts.
Fascinating. It's like we're creating a GPS for wildlife, but instead of avoiding traffic jams, it's helping them navigate through our human-dominated landscape. Now, Tom, here's where it gets really interesting. How does AI handle the needs of multiple species? It's not like we can build a highway just for elephants and call it a day.
You're right, Mark. It would be quite a sight to see an elephants-only lane. But jokes aside, this is where multi-objective optimization algorithms come into play.
Multi-objective optimization? Sounds like what I do when I'm trying to watch TV, eat dinner, and text my friends all at the same time.
Close, but with less spilled food. These algorithms balance the needs of diverse species while minimizing conflicts with human land use. It's like planning the ultimate nature theme park where every animal gets their favorite ride.
Fascinating. So we're not just creating corridors, we're orchestrating entire ecosystems. It's like SimCity, but for real and with actual consequences for biodiversity. You know, Tom, if we map this out on a worldly map, we'd see AI-driven analysis tools moving rapidly from custom-built to product-like offerings.
Absolutely, Mark. And that shift is really democratizing access to these powerful conservation tools. Let's dive deeper into this with a worldly map. Mark, can you walk us through how habitat connectivity analysis fits into the bigger picture?
Certainly, Tom. If we start by identifying the key components, we have raw data sources like satellite imagery and GPS tracking at the bottom of our map.
I see. And how does this affect the overall conservation strategy?
Well, given the positioning of these elements, we can see that as AI analysis tools become more commoditized, the focus shifts to higher-level planning and policymaking.
Fascinating. So the key takeaway from this map is that AI is enabling a shift from data collection to strategic conservation planning?
Let's compare two approaches using worldly maps. In the first scenario, without AI, we see manual data analysis as a major bottleneck.
Interesting. And in the second scenario with AI?
Well, we'd see a different arrangement where AI tools have moved to the right, becoming more utility-like, freeing up resources for more strategic activities.
So the key difference is in how these AI components evolve. enabling a more proactive and large-scale approach to conservation.
Now let's look at the draft Wardley map provided. It's fascinating how it positions various components of habitat connectivity analysis along the evolution axis.
Indeed, Mark. It's like watching the technological food chain of conservation. The raw data is the plankton, and AI analysis is the whale, if you will.
Great analogy, Tom. And just like in nature, we see interdependencies. The map shows how advanced AI tools rely on the evolution of data collection methods and computational resources.
Exactly. And strategically, this map suggests that conservation efforts should focus on developing those higher-level planning and decision-making tools, as the underlying technologies become more commoditized.
It's like we're building a high-tech treehouse for Mother Nature, with AI as the sturdy branches supporting the whole ecosystem of conservation efforts. Well, folks, we've journeyed through the digital wilderness of AI-powered habitat connectivity. From satellite eye views to multi-species matchmaking, it's clear that technology is giving nature a helping hand, or should I say a helping algorithm.
Indeed, Mark. It seems the future of conservation is written in code as much as it is in the genetic code of species. Who knew that the path to preserving biodiversity would be paved with pixels and data points?
As we sign off, remember, whether you're a tech wizard or a nature enthusiast, there's a role for you in this brave new world of digital conservation. Until next time, keep your circuits green and your carbon footprint small.